Okay, in this problem, we are in lesson 4.5 in the skills practice. And for these questions, you're supposed to write each arithmetic sequence as a linear function. Then you've got to graph the function for all integers n such that n is greater than or equal to 1 and less than or equal to 10. In other words, you're going to be graphing it from 1 to 10. So if you were to come up with a series of numbers, the whole series from 1 to 10, you just have to graph those out. That's all you're doing. The simplest way to do these is to come down here and solve your equation for the first 10 numbers and actually write those numbers out as a sequence. So if this is my explicit formula for my function, I can go in here and start putting in different values of n to figure out what it is. Now, some of the work that's already been done here is taking the equation and trying to solve it for just n, so I don't have to worry as much about doing each step of the equation with n inside the parentheses. But I'm going to go back and I'm going to start with that same expression to start off with. So it's negative 50 plus 15 times n minus 1. And for the first one, I'm going to say, well, what happens if n equals 1? And I'm going to put that 1 into my expression and see what happens. So negative 50 plus 15 times 1 minus 1. I do my parentheses first, so 1 minus 1 is what? 0. So this is 0, 15 times 0. Then I do my multiplication next, which 15 times 0 is just 0, so these are gone. And what I end up with is 50 is my starting term. So my first term is negative 50. And in fact, probably to make this a little bit simpler over here, I'm going to write a series and make a little XY table, or in this case, it's going to be A and A sub n. So when n is equal to 1, sorry, n and A sub n. So when n is equal to 1, A sub n is equal to 50, negative 50. If I do it for 2, I come along here and put 2 in for my n. I get negative 50 plus 15 times 2 minus 1, which in this case, this ends up being 1. So 15 times 1, and negative 50 plus that. So what's 15 times 1?
Times 1, 15.
15, there you go. Negative 50 plus 15 is equal to how much?
Oh, wait, okay.
You can use a calculator if you need to.
I know it's you, Eric. I know it's you. Show yourself.
Negative 35. And if you'll notice here, the difference between these is adding 15, which is exactly what my growth rate term is over here. So I'm going to put that in green because that's what I'm trying to use for my growth. So if you look here, this is my growth. And that is how much you add by every single time over here. So if I keep on going, I could do it again for the third one. I'll say a sub 3 is equal to negative 50 plus 15 times 3 minus 1. So 3 minus 1 is how much? 2. So 15 times 2. So 15 times 2 is what?
30.
It's 30, so this is 30. So it becomes negative 50 plus 30. And what's negative 50 plus 30? Negative 20. So a sub 3 is equal to negative 20. So when n is 3, then this is equal to negative 20. And again, it goes up by the 15 amount that you saw the last time. So there you go. You got the next number. And if you keep on doing this, if you add another 15 each the next time, what is it? What's negative 20 plus 15? Negative 5. If 5... Positive 10. And then what's 10 plus 15?
25.
25. Now that you're in the positive numbers, it's a lot easier. So what's 25 plus 15?
40.
40. What's 40 plus 15? 55. What's 55 plus 15?
70.
70. What's, 70. And what's 70 plus 15? 85. Okay, now's where the time when you need to come to graph it. So you go all the way from negative 50 all the way up to positive 85. That means on this graph, at the lowest point you're going to get, you're probably going to want to be at least negative 50 or lower, and the highest you're going to get has got to be at least 85. So what's the total distance from here to here? From negative 50 to 85, how far did you travel total? Can you close the window, please?
Yeah, I got you.
It's more than that. If you think about this,
Can I divide it, or like?
here, I'm going to draw kind of an example up here. If you're going all the way from negative 50 to a positive 85, how far did you travel from here to here?
A lot.
Okay, break it down into two pieces. How far did you go from negative 50 to 0?
50.
So you went 50 from here to there. And how from 0 to 85, how far did you go?
85.
85. So what's the total distance? And add them together, right? So 50 plus 85 is? 100 what?
135?
135. Perfect. Good.
Really?
Yes. So if you need to go 135 from here to here, and you have 10 lines to go, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines.
You can go count by 13 by
Okay, you could try to count by 13 and a half, but that's ugly. That's really, really ugly. The simpler way to do it would be go to the next easiest counting number. In other words, if you go to the next, like, if you want to count by numbers, the simplest numbers are the numbers that we normally count with money. So what's the next highest denomination of money you would use?
20.
20, yeah, exactly. Because if you divide that 135 divided by 10, you get 13.5, and that's ugly. So the nearest one is going to be 20, counting by 20. So you're going to want to count by 20 every single line. If I'm going to do that, I'm going to probably want to put not start at negative 50, like I have, negative 60 is the nearest count of 20, and then count up by 20. So negative 40, negative 20, 0, 20, 40, 60, 80, 100, 120, and 140, and that got you where you needed to go. It went all the way from negative 60 all the way up to positive 140, which is lower than your lowest number and higher than your highest number, so you're good. So, if you want to do that, now you've got all the numbers. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So you're going to graph that out. On 1, where should I put my first dot?
Like right in the middle.
Yeah, so go to put it there. Now what about number 2?
35.
Uh-huh. There you go. And you're going to keep on going. In fact, I would just go all the way up to 10 and doing that at 85. There you go. Keep going. There you go. And that's exactly what your pattern should look like. And you can keep going. Yep, there you go. There you go. And you notice it has that straight line look of a linear function, or an arithmetic sequence, because they will all go in straight lines. And you'll keep going all the way on up, and there's your graph.